morning. Let's go ahead and get started. Okay, like I said, we're going to begin with questions from 5.1. But I'm going to say just a couple of things about the test. First of all, I want to say I'm very proud of all of you. You've done a great job of getting into the test and making proctorio work. And some of you have done a really fantastic job of showing your work in my stat lab. You guys are probably my best class in general as far as showing your work. So you're doing a really good job. I can tell some of you practiced a lot on using the typing tool. And one thing I want to mention to you is make sure you always have the printout of the formula sheet. And actually, you can use, as we go along, you can use the formula sheets that we've already had. So when you take test 3, you may use the formula sheet for test 1 and 2 and 3, plus the sample space handout and that table, the Z table that I put in the unit 3. You're going to need all of those. In fact, when you take test 3, you won't be able, it will be pretty difficult for you to do if you haven't printed out the Z table. Now, the grade in Blackboard should be the same or higher than the grade on test 2 in my stat lab. It will be higher if you earned the 5 points for the homework or if you earned extra credit on that last problem. On the last problem on the test, you'll see everybody got the point for that because I didn't want it to count against anybody. So that actually added a few points to everybody's grade, but that's okay. So it's like a small built-in curve. Let me think what else I wanted to say about test 2. I think that's it. Make sure that you keep up with the homework and are ready in time for test 3. And I believe that's all I needed to say about test 2. If you have any questions, be sure and hang out. Stick with me during the break. Oh, I'm going to tell you something. My internet connection is doing super weird things today. I have to keep switching between 2 accounts. So if I lose you, just hang on. I'll reconnect as quick as I can, okay? So I apologize for that in advance. And I think that's all. I think we're ready to move forward unless somebody has a question. Kendra?
Okay, I'll miss the 3 different formula sheets that we needed for test.
Just all of them. You can use any of the formula sheets up to the one for the test. So you can use, usually the only one you need is the one for that particular test. But for the next test, for test 3, your test 1 formula sheet will come in a little handy if you need the formula for a Z-score. So basically, you can use any of the formula sheets on the tests. Does that answer your question?
So the last one will be, or the next test will be test number 3, correct?
Yes.
Okay.
Okay, guys, we're going to do questions. Hopefully some of you got to some of the 5.1 homework. Did anybody, if you have a question about anything, type the problem number in the chat that you would like to see. Or you can turn on your mic and tell me, but if you type it in the chat, everybody will be able to see which problem we're working. Okay, well, if nobody has any questions, maybe you didn't have a chance to work on it between Monday and today. That's okay. We're going to be going over, we're going to be doing it more as we do the 5.2 questions. So Christina says number 18. Okay, so let's use number 18 as just a review for 5.1.
Okay, yeah, I did have an extra question. Test for test number 1, 2, and 3. I'm not sure how well I did on those first two. So is that going to show, like, how would I be able to fix that first two tests?
It's in Blackboard. It's also, you can review it if you go to anytime you want to look at your grade for a test, go to in my stat lab. And in the menu, you'll see something that says gradebook. And then you can find the test. You can see how you did on any test by clicking on review. Also, the final grade will be posted in Blackboard, also under, I think it says gradebook in Blackboard as well. Okay, so Christina, you were asking about number 18. So this is 5.1, number 18. And I'm going to write some of the information down. So if I was taking this test, and let's suppose this was a show work problem. Some of you are doing a really great job of showing your work, but some people, you're not really showing me what you're doing. You just put your answer there, or you write things. Now I have to say, you guys have the best as far as being able to read it is pretty good, but I am having difficulty. But sometimes you're not showing enough steps, or you're not following the directions. So you want to be really careful about following directions and showing all your steps. So if I was going to show the work on this one, it says a standardized exam scores are normally distributed. In a recent year, the mean test score, so I'm going to write, remember the symbol for mean is mu, and they are telling me the test score was 1506, and the standard deviation, which is sigma, little sigma, is 319. This is the given information, and I would write this even on my work. And then it says the test scores of 4 students selected at random are, so they are giving us test scores for 4 students, are 1,940, 1260, 2190, and 1410. Find the z-scores for each value and to determine if any of them are unusual. So for each of these test scores, we want to find the z-score. So this one's not a probability question. This is just more practice finding z-scores, which was what we did, and that was on test 1. So for example, the first one, it says the z-score for 1,940. Now remember, your test scores, those are your x's. Okay, so when you're finding z-score, the formula, and try to get in the habit of writing the formula down every time in your work. Show the formula. The formula for z-score is x minus mu divided by sigma. So when I find the z-score for this one, I have 1940 minus mu, which was given as 1506, and divided by sigma. And z-scores, we always round to 2 places. Let me find my calculator. So I'm going to put in 1940 minus 1506 divided by 319 equals, and if I round that to two places, it's 1.36. And z-scores, that is our default rounding. If you don't remember from test one, is to round z-scores to two places. Basically what that means is that this test score is 1.36 standard deviations above the mean. Because it came out positive, that means it's above the mean. So I'm going to put in 1.36 right there. And check the answer. So it wants you to do that for all four of these. So when I do 1260, now I can leave that, if I have an editable calculator, I can leave this in my calculator and just adjust that first number. And that will make it go a lot faster. So in my calculator, I'm just going to change that 1940 to 1260. And that gives me negative 0.77 to two places. That means that test score is below the mean because the z-score came out negative. Okay. And you probably don't have to put the 0 in. So it's going to ask you for all four. Let's jump to the last question. Then it's going to want to know which ones are unusual. So unusual, remember, is when the probability is less than or equal to 5%. When you're talking about z-scores, I think I mentioned this last time, but when you look at your normal curve, so here's a z-score of 0. Actually, I'm sorry, I did that wrong. And if you remember, 95% by the empirical rule are within 2 standard deviations. So any z-score that's over here bigger than 2 or over here less than negative 2 is considered unusual. Now, so far, neither of these are unusual. By looking at these, if I had to guess, maybe this one is 2190. If its z-score is bigger than 2, then that means it's unusual. So remember, by the empirical rule, 95% of the data values are within 2 standard deviations, and the number of standard deviations is the same as the z-score. So that means that this little tail out here and this one over here are the outside 5%, which means the probability of those even together, that one plus this one is 5%, because it's the rest of the area under the curve. And so the probability of a z-score being bigger than 2 is actually 2.5%. The probability of a z-score being less than negative 2 is also 2.5%. So basically we say if a z-score is bigger than 2 or less than negative 2, it's unusual. Does that help, Christina? Okay, good. The big thing on computing z-score, guys, is this right here. The parentheses. Parentheses are really important. Okay, when we get closer to Christmas, I have a Christmas song about parentheses. Maybe I'll sing it. But in the meantime, just know those parentheses are really important. And if you leave them off, you will not get the right answer. Unless you do the subtraction and get an answer and then divide. Then you'll get the right answer. If you want to put that whole thing in your calculator, you've got to use parentheses. Right? Any other questions from 5.1 before we go on to 5.2? We're actually not going to learn anything new in 5.2. We're just going to learn how to do a different kind of problem. So we're using the same ideas that we used in 5.1. You're going to need your z-table. So if you don't have your z-table printed off, please make sure that you do that. And at least for right now, pull it up on your device. It'll be under Lessons in the Unit 3 folder, is the z-table. And remember, it's 2 pages. The one side has positive z's and the other side has negative z's. Let's sort of review what that table does for you, and then we'll go on and do some problems in 5.2. So, the z-table. Make sure you print it off. And the z-table, remember, gives the area to the left of a z-score. I want you to memorize that. Gives the area under the standard normal probability distribution curve. That's a lot of words. I'm just going to say curve. Gives the area under the standard normal curve to the left of a z-score. So the table only gives you less than or to the left probabilities. Gives the area under the standard normal curve to the left of a z-score. To the left of a z-score. So if you need to know the area to the right, you have to figure that out using the area to the left. We're going to practice this some more today, so that will be good. And actually, that problem we just did is a good intro into 5.2, because what we're going to have to do today is find those z-scores before we can find the areas. Now, these areas, remember from last class, correspond directly to the probability. So what the z-table gives you really is it gives you the probability that a z-score is less than some number. That's what the table gives you. It gives you the area to the left, so it tells you the probability that a z-score is less than a certain number. Notice I used z, not x. You have to have a z-score. You have to have that z-score. You have to know how many standard deviations it is above or below the mean in order to find the area or the probability of that z-score being less than to the left. So I have a few problems that we're going to work. And so let me pull up the first one. So 5.2 is really just more. We're going to apply the normal distribution. These are applications of the normal distribution. So let me see. Let me pull up my first example. If you're watching the recording, this is probably pretty small. Okay, so I apologize for that. If you're with me now live, then you can enlarge this so that you can see it. But I'm going to write this question down for you. And so this is like problem number 1 in 5.2. And I'm going to read it to you, and then I'm going to write it down, and we're going to look at it. So it says, assume the random variable x is normally distributed with mean equals, so I'm going to write this information down. The mean looks like 86. And the standard deviation is 5. And it says find the indicated probability. This one says find the probability that X is less than 84. So I've written the problem on the board. We're just going to take our time. We're mainly just going to do examples today. So this is what we're looking for. Now, since they told us this was normally distributed, these data values are normally distributed. What that tells you is that you can use, normally distributed means we get to use the z-table to find probabilities. But the z-table only works if you have the z-score. So the very first thing that we have to do with this problem is we have to take this. Notice this says X. The table gives us the probability of Z. So the first thing we're going to have to do is take this data value and find the Z-score for it. So our step one is find the Z-score for X equal 84. And so my work, the work for this, always when you're finding Z-scores, write this. You might not write the formula every single time, but let's put it at least down here. It's X minus mu divided by sigma. And we're going to do here what we just did on that question that Christina asked about. Is we're going to find the Z-score for that so that we can convert this probability question into a probability about Z instead of X. So I'm going to find the Z-score for X equals 84. So parentheses, 84, the data value always goes first, minus the mean. The mean was up here is 86, divided by the standard deviation, which is 5. And we're going to round that Z-score to 2 places. So I'm using the parentheses. This one's going to come out negative because notice the number is less than the mean. 84 minus 86. You guys do this with me and make sure you get the same Z-score I get. Divided by 5 is negative 0.4. That's the Z-score. And if you wanted to do 2 places, you could put a 0. You don't have to. Okay, so I'm going to wait a second, make sure everybody gets this answer in your calculator. If you have any problems, let me know. We have plenty of time today to spend on these examples. This is all we're going to do is example problems. They're all kind of like this, except they're not all less than. So we're going to practice all the different kinds of problems. The difference between the 5.2 problems and the 5.1 problems is that they're going to give us data values instead of the Z-score. 5.1, they always just told us the Z-score. 5.2, they're going to give us data values, so we have an extra step. This is the extra step that we're going to have, is to find the Z-score. That's going to be the extra step. Did everybody get this? While you're doing that, I'm going to check roll. Let me know if you're not getting negative 0.4 or an answer there. Okay, when I call your name, raise your hand. Ariana? Cecil? Diamond? Kayla? Kendra? Christina? Samira? Stephanie? Okay, you can put your hands down. Thank you. So everybody got step 1. Okay, you found the z-score. Let's go to step 2. Step 2 is going to be super easy. All we're going to do is we're going to rewrite the question. Using the z-score. So the question said, find the probability that x is less than 84 becomes the probability that z is less than negative 0.40. So what I did was I just rewrote it, the x changed to z, because I'm changing the data value to a z-score. So that becomes this. Now, this is a 5.1 problem. Now, my step 3 is going to be to draw a picture of what you're looking for. And I want you to start drawing pictures. And I'm going to need to erase so that I'm going to do step 3 up here. So step 3 is going to be to draw a picture and look up the area to the left. Remember, the table always gives you the area to the left of a z-score. So we're going to look up the area to the left of the z-score. We're going to draw a picture and look up the area to the left. So step 3, draw a picture and label the area to the left. And we're getting that from the z-table. So here's what your picture looks like. I'm going to do step 3 up here. So step 3, I'm going to draw a picture. I'm drawing a picture of the standard normal distribution curve. That means I'm using z-scores. You don't have to draw it perfect. When you draw your pictures on the next test in your show work, just don't make it look like, a V, an upside down V. Try to make it curvy, but I won't care if it's how good it is. I like to put 0 in the middle so I can indicate this is the score I'm going to put on my picture. Since it's negative, it's going to be over here. Now it would probably be closer to 0 than what I put it, but that's okay. You just want to put it on the correct side of 0. Since it's negative, I'm putting it on the left. I'm putting it pretty close because this isn't that close. It's not even -1. So I'm going to put negative 0.40 right here. Now, when I draw the picture, I'm going to shade the area that I'm looking for. So I'm going to draw a line right here. Since this is a less than problem, that means I'm looking for the area to the left. So this is the area this is the area I'm looking for. So I'm going to shade the area I'm looking for. That's my question. But I'm also going to look, when I look this number up in my table, the table's always going to give me area to the left. So we're looking for the area to the left of negative 0.40. I'm going to pull up the Z table. I think I have it in here. Yeah. And I want page 1. And I want to test out my pen. I think might be working again. I'm going to test this out. So let me remind you how to look up a number on this Z table, a Z score. So we're looking for negative 0.40. Negative 0.4. Notice that's right. Let's see. Negative 0.4 is right here. And then the number in the hundredths place is 0, so I want this column. So this right here is the area to the left of a z-score of negative 0.40. I like to always show in red. I like to draw an arrow. So that is 0.3446. Okay, so let me quit sharing this so those of you watching the recording can see what I just did. If you see here, I know that that table gives me area to the left, so I like to always show with an arrow, and I always do that in red. That's the area that I looked up in the table. Now, your last step, and on this one, the last step is going to be especially easy, because as it turns out, the area we shaded is the area we got from the table. That's because this was a less problem. If it's a less than problem, the area that you look up in the table is going to be your answer. So step 3 was to draw that picture, shade the area you're looking for, indicate the area to the left of the z-score that you find in the table, and then your step 4, which is your last step, is to calculate your answer. Now on this one, there's not a lot of calculating to do because the area we shaded to the left because this was a less than problem, but that's also the number the table gave me. So that is my answer. So my answer here is that the probability that z is less than negative 0.4 equals that number, 0.3446. And that is my answer for this one. Okay, now I'm going to give you another one to do. I'm going to give you a few minutes to try it on your own. Does anybody have a question about this before we go on? So let's look through our steps. If we're looking for the probability that x is less than or greater than or between, it could be all kinds of things, a particular number. First, we have to change that number to a z-score. If there's more than one number involved, like if you're doing a between problem, you'll have 2 that you have to change to a z-score. So you need to find the z-score, and I'll put an S on there because occasionally there's 2 different z-scores you have to find. That's step 1. Step 2, rewrite the probability, rewrite the question using the z-scores. So there's where I did step 2, right here. I rewrote the question using a z-score. Step 3, draw a picture. No, step 3 is done up here. Draw a picture. Let's add on here. Shade the area you're looking for and label the area to the left that you get from the z-score. So let's add one more thing here, is to shade the area in the question. So we're going to shade the area in the question and label the area to the left of the z-score. Notice the z-score goes down here on the number line. The area to the left we're going to indicate with a red arrow. Okay, so we did step 3 by shading the area, indicating the area to the left of that z-score that we got from the z-table. And then step 4 is to calculate the answer. On this one, there wasn't much of a calculation because the area we shaded is the area that we got from the table, and so it's all the same, and so that was our answer. Let's do one where it's not exactly our answer and see what that looks like. So I'm going to pull up a second example for you. This is problem 3. I want you guys to write this down and see if you can do the 4 steps that I just gave you. In fact, why don't you write step 1, step 2, step 3, step 4. I'm going to erase this and put this question up here. So I'm giving you a few minutes to do this one, and I'm going to write it here. This is example 2, but it's problem 3 in the homework. It says, assume the random variable is normally distributed. That just means you can use a z-table. The mean is 50. And the standard deviation is 7. And I'm going to write the question. Find the probability that x is greater than 38. In case you weren't sure how to get started, step 1 was to change that number, 38, to a z-score. And make sure you label it. Let's not forget that the formula for z-score is x minus mu divided by sigma. So we're going to label that that's what we're finding. So I want you to look at this. I want to make sure everybody knows how to do step 1. When you get your answer for the z-score, type it in the chat. Tell me what you get here. Let's see if we all agree. So I should be seeing like 8 or 9 answers in the chat. Everybody participate. I just want the z-score. Okay, Christina, good. What did everybody else get? Is Christina the only one who did it? Cecil, did you do it? I'm gonna start calling on you. Did you get the same thing as Christina? Cecil? Ariana? Diamond? Diamond, good. Kayla? Kendra? Samira? Kayla, good. Samira? Stephanie? Are the rest of you still with me? Ariana, good. Good. All right, so if this is negative 1.71, that's the first step. Step 2. Step 2 is a really easy step because for step 2, we're just going to rewrite the question. With the z-score. So up here, this was the question right here. So that question, so the probability that x is greater than 38 is the same as the question, what's the probability that z, you notice I changed the x to a z, that sign is not going to change. And then here I'm going to put the z-score. And that's step 2. Step 3. Step 3 is a really important step. And when I ask you for your work, these are the things I'm going to look for. Step 3. And all the questions from 5.2 basically look like this. So every question pretty much on the test from 5.2, if I ask you to show your work, I'm going to expect to see where you found the z-score, where you rewrote the question. Step 3 is to draw a picture. And we're basically going to label, there's really 3 different things you label. We're going to label that z-score on the axis. I didn't spell label right. We're going to shade the area that we need. Let's say shade area needed. And we're going to look up the area to the left and label that on the picture. And we're getting that from the Z table. So I'm going to draw my picture. I'm going to label that axis Z. We're going to draw a bell curve. I like to put 0 in the middle. I don't require it, but it just helps me put this number in the right place. This is the number, this is the z-score we're going to put on the axis. So since it's negative, we'll be to the left of 0. Negative 1.7, that's pretty far. I'm going to put it down here. 1.71. So that's the z-score there, and I'm going to draw a line down to it. So I labeled the z-score on the axis. So the z-score always goes down here. Notice that says z there. Next, I'm going to shade the area that I'm looking for. And on this one, this is a greater than problem. So the data values that are greater than this one, the z-scores that are greater than this one are going to be to the right. So on this one, we're shading to the right. I would color that in, but that would be a lot of stuff to erase. So if you're shading, you could just put squiggly lines or something, however you want to shade it. Practice doing that in your work. I put a few show work problems, I think, in 5.2, so you could practice doing that. Okay, so I did that. And if you're consistent and like do everything in the same color every time, that kind of helps you learn a process. And then I'm going to label the area to the left, and I'm getting that from the Z table. So I'm looking up this area to the left. I always use a red arrow, and it is always going to be the area to the left. So I'm going to look up that z-score in my Z table. The table's going to give me the area to the left of that z-score because that's what that table gives you. It gives you the area or the probability that a z-score is less than a particular number. So let's go back to our Z table. And we want the negative one again, page 1. And this time I'm looking for negative 1.71. So negative 1.7 is right here. And then I want a 1 in the hundredths place, so I'm looking in this column that says 0.01, and I'm going to cross-reference those. And this is the number I need right there, but it's hard for me to see on this. It's easier to see on a printout. I'm going to look at my actual table. Now, if any of you want to print off a Z table to use, a very nice student made this one for me that's laminated. And if I look up negative 1.71 on that, it's 0.0436, which is really hard to see right there on the screen. But that's what it is. So I'm going to write that on there. So negative 1.71 is 0.0436. Let me unshare that. Hopefully everybody understands how I cross-referenced those numbers on the Z table to get that, and that gave me the area to the left, because that's what the Z table gives you, is the area to the left. Now, step 4, I'm going to do step 4 over here. Step 4 is basically to find the answer, calculate the answer. So remember, my question became the probability that Z is greater than negative 1.71. That was the question. Remember, we rewrote the question. We rewrote it, so the probability that the data value is bigger than 38 is the same question as saying, what's the probability the Z-score is greater than negative 1.71? So we found this. This was the less than. But notice what we shaded was this over here. Can anybody tell me what calculation I should do? What I really want to find is this shaded area. That's the question. That's the probability that Z is greater than negative 1.71. Does anybody know what calculation we should do from this picture to get that area right there that's to the right? What should I do? There you go, Christina. Is 1 minus 0.0436. And by the way, if when you print off that Z table, if you have trouble seeing the numbers, that Z table is available in all kinds of places. And you can even, there's even a Z table probably in the ebook that you can print off. You can also Google and find a Z table that's more readable if you want to. I like it when it has shaded things though, because it helps you find the line. If not, you need to use like a straight edge so that you can make sure you're lining up with all those numbers. So now I'm going to do that calculation. And there's my final answer, so I'm going to put it in a box. There's my answer. So the probability that a data value is bigger than 38 is about almost 96%. That's what that, if I change that to a percent, that's what it would be. Now we're going to give our answers in decimal form almost all the time, unless they tell you to change it to a percent. But that's what it's going to be. So let's go over this one more time when we do a greater than problem. If they give us the data value instead of the Z-score, we're going to have to convert it to a Z-score. If you haven't done the 5.1 homework yet, basically the 5.1 homework starts with questions like this. They tell you the Z-score, and they tell you whether they want the area to the right or to the left, or they might ask a probability. Less than means you're looking for the area to the left, and greater than means you want the area to the right. And then we're also going to practice on an in-between problem in just a minute. So in 5.1, you're basically starting from here, but you should still draw a picture showing the Z-score, shade the area you're looking for, label the area to the left that you get from the Z table, and then use your picture to calculate your answer. Okay, it's 11:26. I'm going to give you one more that I want you to try during the break. I want you to see what you can do on this one. And then this is what I want you to do during the break today, is work on this question. And then when we get back from the break, we're going to see what everybody got and make sure everybody's understanding. So this third example is like problem number 4. Now, if you finish this one, you might want to go do problem number 4 during the break and see if you get it right. Or you might want to go back and do problems 1 and 3 that we just talked about, going by your examples. So this is what I want you to work on during the break. And when we get back, we'll look at all the steps. Be sure to do all 4 steps. Notice on this one, you've got 2 data values you have to convert to z-scores. So this has a little bit more work. You're going to have to convert both 74 and 81 to z-scores before you can rewrite the question with a z in the middle. So I'm going to give you have about 32 minutes. I want you to work on this and make back and do a couple of questions in 5-2. Stop the recording.